So what I'm going to do is cover the first few, the basic aspect of Erlang, looking at data types and so on. So what we'll do in the basic Erlang 1 is cover data types, variables, some rather more complex data structures, and finish off by covering pattern matching. So I'm going to start off talking about the basic Erlang data types. Now, in a way, there's not very much surprise to start with about the data types. Integers in Erlang are pretty much like integers in any other language, except for a few differences. You are allowed to use different base representations for numbers. So if you use the base followed by the hash character, and then the value in that base, that will represent a number in an arbitrary base between 2 and 16. It's possible to write down the integer, which is the ASCII value for a character, by preceding that character with the dollar symbol. And I guess most importantly about integers, and perhaps the biggest difference from other languages, is the fact that integers are by default as large as you like. So once an integer value exceeds a certain amount, certain size, they're converted to big numbers. So it's possible, there's no worry about overflow and so on. You can deal with arbitrary precision within integers. Okay, what I'll do now is just demonstrate. You can see some examples on the slide. What I'll do is I'll show you how you evaluate numbers in the Erlang shell. So here we see a Unix command prompt. We type ERL in order to invoke the Erlang shell. You can tell it's an Erlang shell because it's saying eShell, and also you can see the prompt has changed. So here you see a number followed by a greater than symbol. And that's the number of the expression that is being typed. So the pattern for the Erlang shell is that you type an expression followed by full stop, and you get back the value of that expression. So for example, if we type in 2 followed by full stop, we get the answer 2. If we type in 3 plus 4 followed by a full stop, we get the answer 7. And you can see that the prompts are changing. We're now on the third expression. If you fail to remember to type a full stop at the end, you type 3 plus 4 followed by carriage return, you can see that we are able to continue inputting to that expression. And with this carries on until you type a full stop. So there we've got 3 plus 4 plus 5. So an expression can be input over multiple lines. Now you can see here we've seen some simple integers. We can see an example of a different base. We've got the number 1101 base 2, and that is 13 because it's 8 plus 4 plus 1. And you can see that we get the character code for a character by preceding that character with $. There you see character code for $. Here you see the character code for A. So you can see we have these operations. We have the standard operations you'd expect. We've got multiplication on integers. We've got division. We've got subtraction on integers, and we've got division on integers. That's whole number division, and that's whole number remainder. Okay, so that is the end of the demonstration of the Erlang shell for integers. Floats in Erlang follow the IEEE 754 standard, so they're represented as doubles in a 64-bit representation. They're not tremendously efficient. Initially, I think if you want to get real-time performance from numerical calculations, the advice is to use integers. You can see that the representations are the standard representations, decimal point, or you can have mantissa and exponent. Now I'll show you just a couple of examples of calculating with floating point numbers in the Erlang shell. You'll see in the Erlang shell that we can do similar things to the things we can do with integers. We've got 2 plus 4 times 3.1. We can represent numbers by exponent and mantissa. So you can see that is 2.1 times 1000. And we have a division operator, so 2.3 divided by 2 is given by the division symbol there. If we write 2.3 like 2 divided by 1.3, you can see, sorry, remembering always to put a full stop after an expression, you can see in both of those cases that the integer used there is converted to a float before the division takes place. On the other hand, if we write something like 2.3 rem2, we'll get an error there. We're getting a typical, it's the first example of an error being produced by evaluating an expression. Indeed, the error is that there is a bad argument. This is a standard Erlang error, a bad argument in an arithmetic expression. It's saying it's the operator rem called as 2.3 rem2. It's not pointing, could perhaps point to the fact that the problem there is putting a floating point number as an argument to an integer operation. Okay, I mean that concludes what I wanted to say about floating point numbers in Erlang. So let's move on now to the next data type. So the third primitive data type in Erlang is the atom. And an atom is a constant literal. It simply stands for itself. There are 2 ways of writing atoms. The simplest is to write something that begins with a lowercase letter. So if you start with a lowercase letter, you can use any other letters, integers or underscore within the atom. So you can see on the slide there's person, but there's also start, underscore, with, a, underscore, etc. The other form of atom is written inside single quotes, and within single quotes any character at all can be used. So that is a much more general form of atom, but you must remember to write that within single quotes. So these are similar to static finals in Java. There are things that just can't be. Do I mean static finals? I'm not sure I do actually. You could cut this bit. You can cut this bit out, can't you? You can cut out a bit from this. So these data types are similar to enumerated types in other programming languages. Okay, and I think I don't need to do a demonstration in the shell to show you how these things are produced. So, in Erlang there are 2 ways of forming compound data. There are tuples and lists. And they have a number of similarities. They're both heterogeneous. They can contain data from different data types, all combined into this single composite item. But they have some differences. We'll start by looking at tuples. So tuples are delimited by curly brackets, and items are separated by commas. In the examples you can see on the slide, we have a data type beginning 1, 2, 3, followed by the atom BCD. So that contains a number and an atom. It can consist also of atoms or indeed other tuples. So in the 4th example there you can see that we have an atom. The second item is itself a tuple, whose first item is an atom, the second item is a number, and the third item is an atom. The third example is a very important one because it shows an important Erlang convention or idiom, that you represent the type that a tuple has by using the first field to tag the data. So you're saying that this is a representation of a person by having person in the first field. And then the fields that follow, in this case, are atoms for Joe and Armstrong. But you might record coordinates by having something like the first field being Cartesian. Let's say cart. And then followed by 2 numbers which represent positions on a plane. So this is a very general form of data representation. A tuple is a fixed format. So the example, similar things in other languages would be records in Pascal or tuples and pairs in a language like Haskell. The reason that it says tuples are used to store a fixed number of items is the fact that when you analyse a tuple in Erlang, and we'll see this later on, all you can do is pull out particular fields. It's not possible to decompose a tuple into subtuples. And that's the crucial difference between tuples and lists. So a list is used to store items which come from different data types, just as is the case for tuples. But it says they're used to store a variable number of items. The way to interpret that, I think, is to see that a list is built up by adding items to a smaller list. So a list can be decomposed into its head, its first element, and the remainder of the list. So in that sense, a list is dynamically sized. Now, the way that strings are represented in Erlang is that they are simply lists of ASCII values, and I'll show you that in the terminal in a minute. Lists are delimited with square brackets, in contrast to tuples, which have curly brackets. But again, the elements are separated by commas. Now, I think the crucial thing about, here we see a number of examples of lists. Again, a list can contain data from different types. It can contain other lists as elements. It can contain tuples as elements. So lists can contain lists or sublists as elements. Tuples can contain lists or tuples. So the types can be arbitrarily matched. Now, what I think I'll do is show you a few examples in the shell. Right, moving back to the shell, let's have a look at a few examples. First of all, let's see an example of a tuple. Here's a tuple ABC 1, 2, 3. Here's a list ABC 1, 2, 3. You can see those both evaluate to themselves. We can ask some different questions of. Here we're seeing an example of applying a function. We'll see an awful lot of functions in the course of these lectures. But what we're seeing here is a simple example of a function applied to a list. And that's saying that the length of the list, the number of elements that are on the list, is 2. We can also apply that to a list like this. And you can see here the parentheses are matching there as I type. And the length of this list is 2. That's because the list itself contains 2 items. The first is an integer, 1, 2, 3, and the second is itself a list. So 2 elements in the list, one a number, the other a list. Now if I type a list like this, of numbers, it's got 4 numbers in it. What we expect to see as a result is just that list being echoed. What in fact we see back is a string, because strings are represented in lists simply as lists of strings are represented in Erlang simply as lists of integers. And so you see it as a string because that's how it's the Erlang shell chooses to echo that list back to you. If I type this, what we'll see back is and I can ask for the length of one of these strings. That has length 4, as you would expect. Okay, now I think I'll stop for now, talk a bit more about how lists are constructed, and then come back to demonstrate a few more aspects of lists. So the crucial thing is to think about how lists are constructed, and in fact lists are constructed at what's called a recursive data type. And a list is built up in 2 ways. It might be an empty list, which is just written down open square bracket, close square bracket, or you can think of it as being built by putting an element on the front of another list. And the way that is done is by writing open square bracket, the element, vertical bar, the list, and closing square bracket. So lists where and the 2 elements that come before and after the vertical bar are called respectively the head of the list and the tail of the list. And in fact, you can put anything to the right of the vertical bar, but it's typical in Erlang to build what are called proper lists. So those are lists which are, if you like, lists all the way down. So the thing on the right is always a list. So you finish up building a list from an empty list at the extreme right-hand end. And I'll show you an example of that in a second. So lists are the most commonly used data type in Erlang, and many Erlang, it's unusual to find an Erlang program that doesn't do some list manipulation. Here's an example just showing you, the arrow there is showing you that a list is built up in this recursive way. Before I move on to talk about this slide, what I'll do is I will do some more examples in the Erlang shell. So we've restarted the Erlang shell just to clear up the, so we don't have a whole lot of old expressions sitting up there. And let's see an example of creating a list in this way. Well, one way of doing that is simply to write the empty list. So that's a way of creating a list. Another way is to use what's called the const notation. I should have explained this when I was talking about the slides. This is a notation where you have open brackets, element, vertical bar, list, close bracket. So here we've got a simple example of a list with one number. You can see here the first element of the list is 2, and the tail of the list is the empty list. We see that what we've got here is the list with just 2 in it. We could build up a more complicated list this way. We could write 45 before the vertical bar, and then after the vertical bar we could write the list 2, 3, closing square bracket and full stop. And there we see we've got the list 45, 2, 3. It's just worth pointing out that the way the Erlang shell works is if you write a list of numbers which don't make sense as printable characters, you'll see back the numbers. But as we've seen earlier on, if we write a list with, say, the number 65 twice in it, what we get back is a string representation, because those letters are printable. Now I think what you can see here, I could show you one last thing, and that is that you can put anything you like after the vertical bar. So we can write 45 vertical bar 3, and that's just represents itself. It stands for itself. It's an item whose first element is 45 and whose tail is 3. But you can see that is not a properly constructed list, because the tail itself, 3, is not a list. So perhaps what we meant to write here was 45 vertical bar, list with just 3 in it, followed by full stop. And there we've got, I think that was what we were aiming to do. And most programmers in Erlang use only what are called proper lists, that is lists that are terminated as you deconstruct them by an empty list. The final slide on lists is talking about some of the operations that we can perform. What I'll do is I'll show you those on the whiteboard. Two important operators on lists are plus plus and minus minus. What plus plus does is join two lists together. So 1, 2, 3 plus 4, 5, 7 is the list 1, 2, 3, 4, 5, 7. What minus minus does is remove elements from a list. So if we have the list 1, 2, 3, 2, 4, and we subtract 2, 3 from that, what gets removed is the first occurrence of 2 and the first occurrence of 3. So the result of doing that is the list 1, 2, 4. You can see that it's not removed that second occurrence of 2. Just to be clear, something that can be confusing is the difference between plus plus and cons. So it's important to realise that you write a list plus plus, a list, whereas you write an element, vertical bar, a list. So if I write 1, 2, plus plus 3, 4, I get the list of 4 numbers. Whereas if I write 1, 2, cons 3, 4, I get a list with 3 elements. The first is a list 1, 2, the second is 3, the third is 4. So it's important to realise that those two operators do quite different things. What I'll do now is I'll move on to the next part of the presentation, and that's about variables. Variables in Erlang begin with a capital letter, and after that you can put small letters, you can put underscore. And if you put an underscore on its own, that's what's called a don't care variable. Now also a variable can begin with an underscore, and that, we'll see a bit later on, is like a don't care variable, but has slightly different properties. But we'll see that when I do a demonstration a bit later on. Okay, now what I'll do now is show you how variables are used in the shell. Okay, let's have a look at what we can do with variables in the shell. So what we do is, here we've got a variable a, and what we can do is assign that the value 23. What we see as a result, what we get back as the result, is the value that's been assigned. But then we can use that value of a. You can see a is 23. We can ask for a plus a, or we can ask for a minus 10, for example. Let's try and assign a again. We want to add one more to it. Whoa! We're getting an error here. And what that is showing us is that assignment in Erlang is single assignment. You can only assign to a variable once. We've assigned a the value 23, and it keeps that value. I'll come back a bit later on when we talk about pattern matching to explain precisely what's going on in this error. But for the moment, just beware, Erlang is single assignment, and so you assign once. If you want to, in the shell, forget the value of the variable a, you can type f little a. And now we could, within the shell, assign the value again. But when you're programming inside an Erlang program, and you want to assign to variables, you can't do this forgetting. So you can't use variables in the way you would use them in a traditional imperative programming language like C or Java. It's crucial to realize that. It makes Erlang a lot easier to use for concurrency. So it's a good thing. Right, what have we seen here? We've seen an assignment of a variable. We can also have a look at assigning to the, that again has the value 23, but it's not made an assignment because the thing on the left of the assignment is a wildcard. So what we see on the next slide is just a reminder of some of the things that we saw in the shell. Variables can be used to store, we saw in the example, we only saw some simple examples of integers. Variables can be used to store any sort of data structure. But we've seen that the value of a variable can't be changed. They can only be bound once. And also, there is no types. Variables in Erlang are not typed. A variable can be, a value of any type can be assigned to any variable. What we see now is an example of a complex data structure which pulls together atoms, like person and Joe enclosed in single quotes, lists like the list 3597, tuples, which we see in the first line. You see the tuple person, Joe Armstrong. And so those put together can represent quite complex data structures. Now we create those values by writing down those sorts of complex structures. But what's one of the nice features of Erlang is that Erlang has pattern matching, which allows us to analyze and make conditional code dependent on different structures. And that's what we're going to look at next in the section on pattern matching. This really just reminds us of what's going on in using complex data structures. They can be arbitrarily nested. They can contain bound variables, so if you've assigned a list to a variable, you can then use the value of that list within another data structure. And one very important thing to emphasize is that you don't have to worry about memory allocation, or even more importantly, deallocation. Erlang is a garbage collected language, so allocation is automatic, and deallocation is performed by the garbage collector. In fact, the garbage collection in Erlang is very sophisticated. As you're probably aware, Erlang is a concurrent language, and garbage collection is per concurrent process. So it's a very fine-grained and very optimized garbage collection. But let's move on to pattern matching. The general form of pattern matching is that on the left you see a pattern, on the right you see an expression. Between you see the equal symbol. And pattern matching has three roles in Erlang. It's used for assignment, it's used for execution of control flow, and it's used for destructing compound data types. And we'll see some examples of that on the slides that follow. So first of all, we have an assignment A equals 10. That succeeds and binds A to 10. We see further down the slide, we see some examples of assigning a tuple of variables to a tuple of values. And at the bottom you see an assignment of a constructed list to a list. Let's move to the terminal and see some of those things in action. Right, let's have a look at how this works out in the Erlang shell. We've seen simple assignment already. The variable A is assigned the value 10. But we can see a different sort of assignment here. We have a tuple of variables on the left, and we can have a corresponding tuple of values on the right. Now we see as a result, the result is the value on the right hand side. But now we have made separately an assignment to B and to C. So there we see that that's one mechanism in Erlang for extracting values from complicated data structures. You put a pattern on the left which matches the value on the right, and the individual variables in the pattern on the left, in this case B and C, match the values on the right, namely 34 and 12. Now we can also do some checks as we do this. So for example, if we assign DDE to 23, 23, 12, we'll see that succeeds, and D has got the value 23 and E has got the value 12. But it's interesting, if you look in the pattern, you'll see that we repeated the variable here. And so this was only successful because we had 23 on both sides. Let's have a look at that, what happens if that fails. We put FFG and we try and match that with 23, 24, 12. You can see that now we've got an error from this because there's been no match of the right hand side value. The right hand side value is indeed what we've written, 23, 24, 12, but the pattern on the left is trying to match that in such a way that there's the same value for the first F and the second, and that can't be the case because the first F is matched to 23, the second F is matched to 24, so that fails. And this is one of the first example we've seen of a pattern match failing. Well, it's not, in fact, it's the second example, because what happens if we write A equals 11? Well, we've already, on the first line of this shell, assigned A to 10. So if we now assign A to 11, we get exactly the same error, because what is happening is that we're matching the left-hand side variable, which we know already has the value 10, to the value on the right, which is 11. So that fails, but what will succeed is that, because the variable on the left-hand side already has the value 10, and that's equal indeed to 10. So we've seen there that pattern matching can succeed, as it did in line 2 and in line 5, but it can fail, as it did here, because of a failure to match. The pattern on the left fails to match the value on the right. It fails to match in line 8 because the two values 23 and 24 are not equal. It fails to match on line 9 because the A is already has the value 10. Okay, so we've seen there an example of a failure. Another way that a pattern match can fail is that we could write something like a tuple with 2 elements on the left and a value with 3 elements on the right. That's failing again because the pattern on the left is expecting a 2-element tuple and we're trying to match it with a 3-element value on the right. Now, I talked earlier on about how lists were constructed, and we saw that one of the ways you can construct a list is to write something like a head const onto a tail, and that will give us a value. We could assign that. Let's assign that to n. Oops. So now we've got this complex value m. How could we analyse that? Well, the way we can analyse that is to put a pattern on the left-hand side, and the pattern here is the head p and the tail q, and match that with m. What should we expect to see? Well, it's been successful, and what we should expect, what would be the value of p? P is the head of the list, so we'd expect that to be the first element. Q is the remainder of the list, so we'd expect that to be a list, and that is that is the number 34. But here you're seeing one of the features, one might call it a bug of the shell, that the shell is thinking, oh, the character code 34 is something I can print, and in fact it's the double quote symbol. But that is actually equal to 34. Let's just check that by typing q plus 34. Now, of course, that is wrong, because what I've written is a list being equal to a number. What I should be writing is q as the list with just 34 in it. And let's see if that works. And that does work. Good. So I think that's shown us, and that's shown, I think, very clearly how lists. I said earlier on that lists were analysable as a head and a tail, an element plus a sublist, and that's rather different from a tuple. The only thing you can do to take apart a tuple is to take all its elements, whereas with a list, what you can do is take its head and have the remainder of the list as its tail. And we'll see that that's very useful in programming, in recursive programming of all sorts of functions over lists. Now I think what we've done here is we've seen the 3 elements of pattern matching. We've seen assignment, so we're getting values assigned to variables. We've seen testing, you can test, for instance, whether 2 values in a pattern are equal. And we've also seen that portions of a list can be extracted by pattern matching. So what I'll do, I'll just run through some slides which summarise that, and that will bring us to the end of this first section on basic Erlang. So we've seen this general construction of pattern equals expression can be used for assignment. It was the simple thing we did to assign a value to a variable A. But we've also seen now that that can be an assignment to a more complex. If we do an assignment B, C to the tuple 3, 4, that finishes up with b being equal to 3 and c being equal to 4. So that's assigning a number of values. Now what we can see next, what we've seen in that there can be a test aspect to assignment. So we can, if for instance we put the same variable into a pair and assign that to 3, 4, this will fail because we're expecting two equal values and we're presenting two different values. On the slide you see some other examples of failure, a list of 4 variables being assigned to a value of 3 variables. In the third example we see a successful pattern match of A, B to the first 2 elements of a list, and the remainder matches the 5 elements 3 up to 7. But another failure is to try and match the head and tail of an empty list, because an empty list doesn't have a head element. So that's an unsuccessful pattern match. And finally, what we see is extraction of values. And in the examples here, you see extraction of complex values from complex data structures. So we're extracting, in the first example, we're extracting an atom ABC in the variable A and a constant integer 22, which occurs twice in the value, is being extracted into the variable B. So writing complex patterns that involve variables, atoms, numbers will match successfully with the values that have those corresponding atoms, numbers and so on in a corresponding position. So we can do complex pattern matching and we can simultaneously extract elements from a complex data structure. So what we've seen in this section is we've seen the basic data types of integers, floats and atoms. We've seen how strings are represented as lists of integers. One thing that we haven't mentioned, because there isn't this type in Erlang, we haven't mentioned booleans. And booleans, the boolean type is simply represented by the atoms true and false, and the collection of operators over those atoms. We've seen how Erlang has single assignment. Variables are identifiers that begin with a capital letter or an underscore. We've seen how those are assigned to. We've seen how they're used in complex patterns for testing, assignment and extracting values. And we've seen how complex data structures can be built using combinations of atoms, atomic types like atoms, numbers, tuples and lists, which combined together can represent very complex values. So that concludes the basic Erlang section 1. What we'll do next is move on to basic Erlang section 2.